find the sum of the arithmetic series, there's a couple pieces of information that we need to know. I always need to know my first term and my last term, because again, if we're building a rectangle, that rectangle is first plus last. So that's the height of the rectangle. I then need to know my number of terms and divide that by 2. So for these problems here, we're given the first and last term, but what we do not know is the number of terms. So for each one, I need to figure out that number of terms. To do that, I'm always going to use my T of n equation, the sequence generator. So in first term form, it is 5 plus, and now my common difference is also 5. Now, in order to figure out the number of terms, n, I'm going to take 400 and put it in here for T of n. So now I have 400 equals 5 plus 5 times n minus 1, and I solve for n. That'd be 395 equals 5 n minus 1. Then I'm going to divide that by 5. And then adding the 1, I get 80 terms. So if I have 80 terms for this problem, I'm now going to take the first term plus the last term times my number of terms divided by 2. So when I do that, I get a total of 16,200. And that is the sum for problem A. Problem B is going to be the same steps. So my T of n equation, I'm going to set equal to 398. My first term is 3. My common difference, again, is 5. So now I'm going to go through and solve. Subtract the 3. Again, divide. And for this one, again, I'm going to get the same answer I got before. 79 equals n minus 1, and I'm going to get n to be 80 again. So on this one, I'm going to end up having 3 plus 398 times 80 over 2. That's going to then give me a sum of 16,040. Now, there's a couple of things that you may or may not notice from this problem and problem A. First of all, every term is 2 less than the previous term. So when I look at that, even ends at 400, and it ends that the second term or second series ends at 398, I should have then known already that there was going to be 80 terms, because it's going to have the same number of terms as A. Another thing to take a look at then, based off of lesson 10.1.3, we work with series like this, is if there are 80 terms and each term is 2 less, it's going to be 80 times 2, which is 160 less than the sum for that one. So if I thought back to problem A, which was 16,200, B is going to be 160 less. So when I subtract those, I get, again, my sum here. So a different way of looking at it. But again, you can always just go through and do this here and do the steps that we did there. So then problem C, I'm going to go through again and do my same thing. 14 is not my last term. My common difference this time is now a negative 6. So 80 is my first term minus 6 times n minus 1. So now I'm going to subtract the 80 from both sides. Get a negative 66 equals a negative 6 n minus 1. Divide by a negative 6, I get 11 equals n minus 1. And my n is 12. There are 12 terms. So the sum first plus last times number of terms divided by 2, 564.